In this video, we're going to be looking at giant covalent structures. A giant covalent structure is a structure made up of many non-metal atoms covalently bonded together. Out of the 4 giant covalent structures we're going to be looking at, 3 of them are made of carbon. Diamond, graphene, and graphite are all made of carbon atoms. Because they are different forms of the same element, we call them allotropes. So diamond, graphene, and graphite are allotropes of carbon. The first giant covalent structure we're going to discuss is diamond. In diamond, each carbon atom forms 4 covalent bonds with other carbon atoms around it in a tetrahedral arrangement. This means that diamond has no delocalized electrons. The properties of diamond are the following. It's insoluble in water, which means it doesn't dissolve. It has a high refractive index, which means when light enters a diamond, it changes direction by a high degree. This makes diamonds appear very sparkly. Diamond has a high melting and boiling point due to the very strong covalent bonds between the carbon atoms. They require a lot of energy to overcome. Diamond is also very hard because of these strong covalent bonds. Due to the fact that diamond does not have any delocalized electrons, it cannot conduct electricity. And because the carbon atoms are held very firmly together by strong covalent bonds, it is a good conductor of heat, as the atoms can pass on kinetic energy to their neighbors very easily. Because of the high refractive index, diamonds are commonly used in jewelry because they form very sparkly gemstones. And because of the hardness of diamonds, they're commonly used in cutting and drilling tools. The next giant covalent structure we're going to talk about is graphite. Now in graphite, each carbon atom is covalently bonded to 3 others, forming hexagonal rings, as you can see here. Delocalized electrons are free to move between the layers. Now these delocalized electrons happen because in each carbon atom there's 4 electrons in the outer shell. 3 of them will form covalent bonds with other carbon atoms around, but 1 electron will become delocalized and will be able to travel freely between the layers. And then between the layers, they're held together by weak intermolecular forces of attraction, and these are not strong like the covalent bonds between carbon atoms. The properties: graphite is insoluble in water, which means it can't dissolve. It has a high melting and boiling point because of the very strong covalent bonds between the carbon atoms. It's soft because the weak intermolecular forces of attraction between the layers mean that the layers can slide off each other. And then it conducts electricity and heat well because of the delocalized electrons. Because graphite is soft and the layers can slide over each other, graphite is commonly used in pencils. And because graphite is very slippery due to the layers sliding over each other, it's commonly used in lubricants to reduce friction. The next giant covalent structure we're going to discuss is graphene. Now, graphene is a single layer of carbon atoms. If you can imagine graphite, if we took one of those layers in graphite, we would have graphene. Now, the carbon atoms in graphene form hexagonal rings. They are covalently bonded to 3 other carbon atoms around them, which means they have delocalized electrons. And these layers are only 1 atom thick. Graphene is a good conductor of heat and electricity because of the delocalized electrons. It's insoluble in water, it has a low density, and it's very strong for its mass. In the future, graphene may be used in the electronics industry to make computer chips and flexible displays. The last giant covalent structure we're going to discuss is silicon dioxide. Silicon dioxide is made up of silicon and oxygen atoms covalently bonded together. The empirical formula is SiO2. This means for every 1 silicon atom, there are 2 oxygen atoms in the giant covalent structure. Properties of silicon dioxide include high melting and boiling points. It cannot conduct electricity because there are no delocalized electrons, and it is also a poor conductor of heat. Common use of silicon dioxide is to make glass. It is the main component of glass.